it involves taking into account different things to do it, like the plausibility of the hypothesis, and put it in the report's introduction as it was an a priori hypothesis. Sorry. So when you are doing research, you have two types of three types, sorry, of hypotheses. The ones that you are anticipated and that are possible to happen, the ones that you didn't anticipate, and the ones that you anticipated but are not possible to happen, and then your results when you did your experiments, that are the results that you had and the results that did not happen. So you have this column that we will need a little bit after. And we will need also know the difference between deductive method and inductive method. So the deductive method is the scientific method, we all know. So you have some theory or background on the topic. You make a hypothesis, you do the experimentation, and then you confirm your results, your hypothesis with your results, and then the cycle goes again. Inductive method, you do an observation, you do the experimentation, then you try to explain the thing you saw on your experimentation, and then you have a theory, and then you start again. So with this, we can go to different types of HARKing. So the first one is pure HARKing. This means that you have the hypothesis you made after you have your results. And when you are reporting your results, you don't mention you have a different hypothesis. So in the report, it's known that your post hoc hypothesis was your only hypothesis. Then you have pure HARKing plus a straw man. You do this one, it's the combination with the first one. And then besides doing a positive hypothesis, you do a negative hypothesis to make the people believe you have something to negate on your paper, on your research, sorry. Then you have suppressed the loser hypothesis. So this means you don't say you have the hypothesis didn't happen, the things didn't happen. So you just say, I had this hypothesis and it happened, and the things that didn't happen, you don't report them. Then you have the post hoc plausibility and the necessity of anticipation. So with this one, you are always making sure with your design of your protocol that the results are going to be the ones that you want to have. So you make sure everything is going to be as you want, and there's no room for errors. And in case if there's an error, you will not report it. And finally, it's the empirical inspiration. That means that when you have your results, you want to dig more in the literature to know if your results fit in something that it's already reported. So you start to create a new hypothesis. And how do we can recognize HARKing on different papers? Well, I have to say that even though these are the journal symptoms of the HARKing, it's not foolproof. So you can find this and the paper is not hard. So it's a little bit tricky. But the first symptom is that one of the variables you choose to report, it's a too convenient qualifier and it doesn't take in account any other variables. The second symptom is that the results are just too good to be true, and you don't know if it's the right answer or no. And then the methodological gap. So this means that there's a little bit of difference between your hypothesis and the way you constructed your methodological, your experimental design, sorry, to have these results. So this kind of disconnections between those two. This is the main reasons for the existence of HARKing, and the paper mentions that most of them are due to the publication industry. So it's always better to put on written good results. So first you have the ideal of confirmation of a priori theory. So everyone always wants to have the reason or to be right about what they are saying. So you look for this. Then the ideal of efficient communication. So this means that maybe you are wasting people's time saying that something didn't work. So it's not of value to report this because people will not care. And then the ideal of telling a good story. So if you have bad results, it will not fit into in the story you want to tell in your paper. And finally, the hindsight bias. This means that when you have your results, you tend to get a little biased and say, I knew this was going to happen. And yeah, that's it.
Can you see the screen and can you guys hear me?
Yes, to both.
Perfect. Okay. So I'll go through the costs of HARKing, which is probably the most relevant thing, right? So if this is happening, what's the issue with it? Why do we care? So first of all, these are the more general issues. The first one, which we've kind of already addressed, is this mismatch between the study design and the apparent goal. Naturally, if you have an a priori hypothesis, you're going to design your experiment in the best possible way to assess whether that hypothesis is correct or incorrect. If your hypothesis that you're coming up with after is different, it's quite likely that the experimental design has not been optimized for that hypothesis, and that's an issue. That also feeds directly into the stats and analysis that's going to follow with the data, especially if you have a hypothesis that you've come up with after the fact. And this changes the way in which you're analyzing the data, changes the way in which you're handling controls. It makes it more likely that there's going to be an unjustified statistical license taken there. Also, the last 2 points are much broader. It presents an inaccurate and distorted model of science. So if people are reading mostly HARKed papers and HARKed papers are being selected preferentially by journals, then we're probably going to end up in a situation where anyone reading these papers is going to get the impression that most of the time these brilliant scientists have a hypothesis, it ends up being true, the data is perfect, it's beautiful, and then when they go to do science, it doesn't end up being that neat and it doesn't really make sense. So this inaccurate representation is a problem, not just for upcoming scientists, but also for the larger public and their impression of science. Personally, I think it's a really clear ethical violation as well. If you're presenting something as one thing and it's actually something else, that's just dishonest and completely unhelpful to the scientific agenda. We come back to this really central issue of a preference for confirmation. So it's a preference of the journals. It's largely a preference of humanity as well. We have this confirmation bias. And I really liked Popper's points here, that it is actually probably more valuable to disconfirm a theory because then we can actually remove it from our current understanding. Whereas if we're just confirming theories, we're just keeping them all alive to be tested again and again. So I do think there is a really important place for disconfirmation. And the two biases that I think are important to keep in mind here is, again, the hindsight bias and the confirmation bias, realizing that we are likely to, once we see the results, have a different perception of what we might have thought was going to be happening. So this is going to end up with a loss of information on one's initial hypothesis. Again, we're lacking explicit disconfirmation of hypotheses. Okay, so the last point I'll talk about before I go into how this is affecting the theory within science is the relative value of accommodation versus prediction. So accommodation would be when you have built a hypothesis to accommodate your data. Fair enough. And I would expect that your data should fit very well within that hypothesis. And ergo, it's not going to be the right data set to test whether this is or is not an accurate hypothesis. Pretty straightforward stuff. But Kerr, the author, did want to go in a little bit deeper, and he actually went into detail a little bit on Bayesian modeling and how that may suggest that there isn't actually an explicit value difference between an a priori or a post hoc explanation. This is based on the assumption that the hypothesis generated either way is evaluated against the same body of evidence, which is usually not the case. Because this is going to need to be larger than just your findings from that experiment. So you're going to need to include something from the literature to test this new hypothesis. And then the question becomes, what are you going to include? And that's a very difficult thing to do well. And certainly in the case where you're pretending it's an a priori when it's not, it just becomes rather invalid. So the damage to the theory, this is where Kerr posits that most of the issues and the costs of HARKing come into play, primarily through the translation of type 1 errors into theory. So rather than publish a negative finding, people might be more likely to HARK a positive one, make a theory and posit this. And then we'll end up with more false positives in our current working theory of any given field. It also tends to favor theories that satisfy rather than optimize. So this means that if you have a theory that kind of fits or kind of works, you're less likely to actually go and try and look at the literature and come up with a theory that will actually be a better fit. So inhibiting the generation of alternative hypotheses. It also favors a narrow theory. So if you're doing this accommodation, you're looking at your data after, it's quite likely the theory you'll come up with will be quite narrow and tailored to fit your data. So it's not really going to be applicable to a wider range of data and ergo not very useful. The opposite can also be true, that people tend to HARK and they can look through the literature, find an old, very loose, disconfirmable theory, and build a hypothesis off that to suit their results. So we also want to avoid perpetuating these really loose, broad, non-specific theories. And the last one is Popper's criterion of disconformity, pardon me, that any useful hypothesis or theory, it has to be able to be disconfirmed. Naturally, if you see the results, you explain them, there's no room there for that to be disconfirmed. So this actually doesn't meet that theory, unless, of course, we start to see replication. So that leads me on to the last part I want to cover with you. Kerr decided that the costs largely outweighed the benefits. This was his summary. It's largely similar with just a few distinctions in wording. But he also, more importantly, took us through some solutions as to what we could do about this problem. Now, if you just jump to the bottom point here, removing HARKed papers completely would be awesome. But as we talked about earlier, the issue is actually identifying them, especially when we have human biases involved that mean the authors may not even be that aware that they are HARKing. So jumping back up to the first point, if we increase awareness of HARKing and its associated costs, it means that scientists can maybe start to be more aware of their own practices and what they're doing, and also the way in which, they're teaching students and working with professors. It just becomes something that's discussed and dealt with. The second part that he raises is that theory must pass some sort of a quality threshold. I think that's a lovely concept. He doesn't actually explain how he would do this, though, and I can imagine it would be quite a difficult thing to do. But yeah, in an ideal world, sure. The next 3 points I think are particularly relevant, that legitimate candid identification of exploratory research, post hoc hypotheses, and negative findings should all be equally as able to publish as a confirmation of a previous hypothesis. And if we do that, then I think we'll take away a lot of the temptation of authors to HARK hypotheses. And then the last one that is presented as a solution is, of course, replication, which is something we talk a lot about here and would largely help, especially removing the type 1 errors that might start to be generated within the scientific theory. Beautiful. So that's all I had to cover with you guys. If you have any questions, please feel free.